Lesson 9.3, Similar Right Triangles. The right triangle similarity theorem says that if an altitude is drawn to the hypotenuse of a right triangle, that the two triangles formed are similar to the original triangle and to each other. So if I have these triangles, on the black one, this is the altitude drawn to the hypotenuse. It goes from the right angle, it's perpendicular to the hypotenuse. If that is the case, the two smaller triangles are similar to each other, and they're similar to the large original triangle. Let's identify the similar triangles and then find x. One way to find the similar triangles is to redraw the triangles and kind of line them up. So there's the large original outside triangle. There's the medium-sized triangle. And there's the small triangle. So now we can see the corresponding parts. So if I say triangle EFG is similar to triangle, so E is this big angle. It would correspond to G in that one, and E in that one. And then we had F, which is the little smallest angle, so it's F in the medium and G in the small. And then the right angle was G in the original, H in the medium, and H in the small. To find x, we need to pick two triangles, two of those three triangles, that have corresponding parts that we know. For example, in the medium triangle, x is the short leg. On the original triangle, 3 is the short leg, so those go together. And then I know the hypotenuse and the hypotenuse. So I did short leg over short leg. And then I did the hypotenuse over the hypotenuse of the medium triangle and the large triangle. Then we can cross multiply and then divide by the 5. So x is 12 over 5. There are some shortcuts we can use. They use the geometric mean. The geometric mean of two positive numbers, a and b, is the positive number that satisfies a divided by x equals x divided by b. Well, if I do that little bit of algebra, I would cross multiply. I get x squared equals ab. And then I have to square root, so x equals the square root of ab. So you just multiply the numbers and take the square root. So what is the geometric mean of 8 and 10? Well, square root 8 times 10. So that's the square root of 80. Let's simplify that. 80 is 16 times 5. The square root of 16 is 4. Square root of 5. Or if you put it in your calculator, you end up with 8.9. Our first shortcut theorem is the geometric mean altitude theorem. It says if the altitude is drawn to the hypotenuse of a right triangle, then the altitude, so this is looking for the altitude, which is the center line from the right angle perpendicular to the hypotenuse, is the geometric mean of the two segments of the hypotenuse. So in other words, CD is the square root of AD times DB. Here's why. If I take the two triangles, the two smaller triangles, I can do short leg over short leg. So the short leg for the medium triangle is CD. Short leg for the small triangle is DB. Over the long leg of the big triangle, over the long leg of the little triangle, which happens to be CD. Then we can cross multiply and square root. Our other shortcut theorem is the geometric mean leg theorem, where it says if the altitude is drawn to the hypotenuse of a right triangle, then each leg, as in AC or CB, is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent that leg. So if I'm looking for AC here, I am going to use the geometric mean of the whole hypotenuse, AB, and the part of the hypotenuse touching that leg. So AC is the geometric mean of AB and AD. BC, this one, is the geometric mean of the whole hypotenuse and the part of the hypotenuse touching that leg. So it would be AB and DB. Again, these come from just the similar triangles. For example, if I do the medium triangle and the large outside triangle, I can say the hypotenuse of the medium triangle over the hypotenuse of the big triangle equals the long leg of the medium triangle, the long leg of the large triangle, which happens to be AC. Cross multiply and square root. So you can solve these either just using similar triangles, which is fine, or these shortcut theorems. Let's find the value of x. Shortcut way is we notice x is a leg. So the shortcut is x, the leg, is the geometric mean of the whole hypotenuse and part of the hypotenuse touching that leg. So we'll have x, the whole hypotenuse is 4 plus 5, or 9, and the part of the hypotenuse touching my leg is 5. This is the geometric mean leg theorem. So the square root of 9 is 3 times the square root of 5. Or about, if you put it in your calculator, 6.7. Let's try another one. Y is the altitude, and we know the two parts of the hypotenuse, so we could use our geometric mean altitude theorem, which says the altitude equals the geometric mean of the two parts of the hypotenuse. So our altitude equals the square root of the two parts of the hypotenuse. So to the square root of 40. 40 is 4 times 10. The square root of 4 is 2, so it's 2 squared root of 10, or about 6.3. Now these can also both be done just by using the similar triangles. On the first one, if I use the medium triangle, and if I use the large outside triangle, x is the hypotenuse of the medium triangle. The hypotenuse of the large triangle is 9. And then the 5 is the long leg of the medium triangle. And the long leg of the large outside triangle is x. Cross multiply. Take the square root of 45, and you get 3 square root of 5. For the second one, on both of the small triangles, I know their legs. So I could do the small triangle and the medium triangle, and I can do the long leg, which for the small triangle is y. And for the medium triangle over here is 8. And then I can do the short leg. For the small triangle, that's 5. For the medium triangle, that's y. Cross multiply. And you get the same answer. So 2 ways to do that.